Welcome to my video lecture on thermal and energy consumption. Myself, Punil Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrasekhar Degree Engineering College. In my previous lecture, we have highlighted about the train movement with time and speed curve, and we have also denoted the several portions of time and speed curve. That is, the total time duration mainly divided into three parts, one for acceleration time, another for free running time, and another for braking time. And in this total part, if we are highlighting about the total graphical nature of the time speed curve, we can see that it is looking like a trapezoid shape. That means using the trapezoidal shape, we can get different timing, different speed calculation, average speed time, trace speed calculations, and also for braking time, how much distance it has been covered. That portion we can calculate by using that time speed curve. In this lecture, we will highlight mainly on these mathematical calculations, and we will understand that how this speed, distance, timing can be calculated using mathematical formations. So in this lecture, we will see mainly the calculation by trapezoidal speed time curve. The total shape is looking like trapezoid only because the portion of acceleration time, then it is free running time, and then it is braking time. And due to that, the total graphical nature of the curve is looking like a trapezoid. And considering that trapezoidal shape, we will now calculate the different portion of the curve. So for doing this one, and we can see that the total curve is looking like a trapezoid. And here we are seeing that alpha is the acceleration in kilometer per second, beta is the retardation in kilometer per second, Vm is the crest speed in kilometer per hour, T is the total time of run in seconds. And in this total portion, we can see that the total timing is mainly divided into three parts. That is, first portion is for acceleration time, this one. Second part is for free running time, this is the T2 portion. And in T3 portion, it is basically braking time. So this part includes the braking portion. So here, if we are considering about the total timing, that means it is combination of this total duration, combination of acceleration time, free running time, and braking time. That means T is basically T1 plus T2 plus T3. Now we will calculate the timing for acceleration, that is for T1. So here Vm is the crest speed and alpha is the acceleration in kilometer per second. So definitely T1 equals to Vm by alpha. Next, time for retardation is second, that is T3. So it will be Vm by V. So definitely if we know T1 and T3 and T is the total timing is known to us, then we can definitely calculate the free running time, that is T2. T2 will be T minus T1 plus T3, and putting this value we are getting that T2 equals to T minus Vm by alpha plus Vm by beta. Now we have to calculate the total distance, and total distance of running kilometers, it is combination of distance traveled during acceleration plus distance traveled during the free run, and third one is distance traveled during the braking. That means our total distance is basically covered by combination of three distances, one for acceleration, second one for free running, and third one is for braking. Combining all these three distances, we will get the total distance actually. Now here, from the first portion of the graph, you can see it is looking like triangular shape, right-handed triangular shape. In the next portion, it is looking like a square, and the third part, that is also right hand triangular shape. Using this mathematical formation of triangle, square, definitely we can calculate the distance very easily. So for first part, half Vn T1 divided by 3600. Second part, definitely for square time, it is Vn into T2 divided by 3600. And third part, again triangle, that is half Vn T3 divided by 3600. So combining these three, we can get the total distance. Now we will substitute the values of T1, T2 and T3 in portion of distance calculation. So we are substituting T1 equals to Vn by alpha, T3 equals to Vn by beta, and T2 equals to T minus Vn by alpha plus Vn by beta. Putting all these two values, we are getting that a quadratic equation combination of Vn, T, S and alpha and beta. We are getting Vn square into 1 by 2 alpha plus 1 by 2 beta minus Vn into T plus 3600 S equals to 0. This quadratic equation for Vn, we are substituting the values of 1 by 2 alpha plus 1 by 2 beta equals to k. We are considering this portion as k. Now considering this k, the equation becomes k Vn square minus Vn by t plus 3600 s. The total quadratic equation is now looking like this. So from there, we can calculate the value of Vn. That is by using Vn equals to T by 2k plus minus root over T square by 4k square minus 3600s by k. Now from here we have to understand that which value we consider, plus value or minus value. Definitely we cannot accept plus positive value, because the value of Vn obtained by using positive sign will be much higher than is possible in practice. That means practically the higher value, if we are taking the Vn as positive, then we are getting very high value of Vn, which is practically not possible. So definitely we will neglect the positive sign and we will consider the negative sign in this case. And by considering negative sign, we are getting that value of Vn equals to T by 2k minus root over T square by 4k square minus 3600s by k. From the above equation, unknown quantities can be determined by substituting the values of known quantities. In that way, we can easily solve. Now we are considering one mathematical problem considering all the constants we have already discussed from the trapezoidal shape of speed-time curve. In speed-time curve, we have already calculated the values of T1, T2 and T3. Then we have calculated the values of distance for the three regions S1, S2 and S3. From there, we have calculated the values of total Vm. Those things we have already seen that how these calculations can be done. So taking the help of this part, we now will try to solve a mathematical problem. So let us consider this problem. A train service consists of the following: uniform acceleration of 5 km per hour per second for 30 seconds. That means the acceleration time for this process is 30 seconds. Now by free running for 10 minutes. 10 minutes free running means definitely 10 into 60, that is 600 seconds. Then uniform braking at 5 km per hour per second. That means braking will occur with 5 km per hour per second to stop, followed by a stop of 5 minutes. That means stopping time is 5 minutes, that is also given. Now we will draw the speed time curve. So definitely 30 seconds, that is the acceleration time, and it is 5 km per hour per second, it is going for 30 seconds, then free running for 600 seconds, and then for 30 seconds this part we have to calculate that how much time is required for braking. Now from the known values we have to calculate the unknown quantities like distance between the stations, second average speed, and third one is schedule speed. So here it is a solution we are considering. Acceleration alpha equals to 5 km per second, that is given. Acceleration period t1 equals to 30 seconds, that is also given. Maximum speed, that is vm, we have to calculate, that is alpha. Alpha is given, t1 is given, so we can calculate the maximum speed, that is 150 km per hour. Time for free running. Free running time, again it is given, that is 10 minutes, that is 600 seconds. Again retardation, that is also given, that is 5 km per hour per second. Now time for retardation equals to m by v, that is 150 by 5, that is 30 seconds. And distance travel during acceleration period, that we can calculate from the previous calculation which we have already done by using the trapezoidal form. These values, half dn values we have already calculated 150. T1 is given 30 divided by 3600, that means 0.65 is our distance travel during the acceleration. Next, distance travel during free running, that is S2 equals to Vm into T2 divided by 3600. Here we have calculated 150, 600, we have also known value, that is 150 into 600 divided by 3600 equals to 25 km. So distance travel during the braking period, that is S3 equals to half into Vm into T3 divided by 3600, that is equals to half into 150 into 30 divided by 3600, that is 0.65 km. Now the total distance between the stations is S1 plus S2 plus S3, that is equals to 0.65 plus 25 plus 0.65, that is total 26.25 km. Now the average speed we have to calculate. Definitely it will be total distance divided by the total time. So it is calculated in hours, so we have multiplied this one with 3600. And this will be 26.25 into 3600 divided by the total timing for acceleration 30 seconds, then 600, that is for free running time, and again 30 seconds for braking time. So 143.18 km per hour is we have calculated from the average speed. Next one is schedule speed, that is S into 3600 divided by T total time plus stop time equals to 26.25 into 3600 divided by total time, that is 30 plus 600 plus 50, that is 660, plus stop time is given in the problem, that is 5 minutes, so 5 into 60. So from this calculation we can get the schedule speed. In this way we can calculate several problems of speed time curve. And from these calculations we can solve different problems related to speed time curve of trapezoidal shape. So first of all, we have to know the procedure of how it can be solved. Second, we have to draw the curve and then for calculation. Several mathematical problems related to this topic is very important. So I will refer that all of you must practice with several problems which is given in different textbooks. Definitely go through those problems and solve it by your own hand, then it will be easier for you. And definitely I will prefer that you can go through the book of J.D. Good of utilization of electric power traction chapter, and you can get several problems related to this, and this is very important chapter and very important topic for utilization of electric power. Thank you for listening my lecture, and